so today I'm going to be going over word problems and when we need to use inverse square law and when we need to use direct square law. Both are going to be when we change our distance, right? So whether we're bringing our tube back or bringing it closer, it's going to ultimately change how much intensity is going to reach that IR exposure. So if we're going to be asking questions about the intensity, that's going to be ISL, and it's going to be weird units that we don't normally work with. And if we're going to be asking something about what kind of technique do we need to use based on the change in distance, that's going to be direct square law. So I tell my students over and over and over, inverse square law sounds cool. For some reason in radiology, everyone always loves to talk about inverse square law, but in reality, we do DSL in lab almost every single day. So almost every single lab I'm doing, hey, we're gonna change the distance to reduce magnification, or we're gonna change the distance to improve spatial resolution. What's gonna happen to our IR exposure? And they should know that it's gonna go down. They can actually calculate it out if I give them an original number. And then if I were to say, okay, I'm gonna change my SID, what should I do to my technique to make it still shoot the same like zero leg technique? That's gonna be a direct square law or exposure maintenance formula. So on the board I have both direct square law and inverse square law written out. I strongly recommend before you take your test that you write out both of these formulas every single time so you don't get confused, because it's very easy to flip an old and a new and when you're squaring and when you're not. Direct square law, the old units are on the exact same plane. So they're directly related, right? So my mass old over my mass new is going to be equal to my distance old squared divided by my distance new squared. Notice that both olds are on the top, both news are on the bottom. Inverse square law is going to be when I'm dealing with weird techniques, weird units like millisieverts or grays or Rankins or something like that. So if I change my distance, how does the intensity on the IR change? Inverse square law sounds really cool, but in reality, we don't care about inverse square law. When am I ever going to take an x-ray and be like, how much is the intensity going to change if I back up my SID? Never. What I am going to say is if I change my SID, what should I do to the technique to fix it? That's the one we're going to be doing all the time. So when in doubt, stop doing inverse square law. It's the stupidest law. Unless you're going to become a physicist, then you do need to do inverse square law. But otherwise, we don't need to worry about how much the intensity is going to change. We just need to know how to fix it. We're x-ray techs, right? So in inverse square law, I is going to be I, right? Inverse intensity. And I have old, intensity old over intensity new equals my distance new squared over my distance old squared. Notice that my olds are now opposite of each other and my news are now opposite of each other. So inverse, right? Direct. So that's how I remember which one is going to be old and which one's going to be new and new. So if we go over to this problem at the board, my original technique of 75 kVp, 20 mass at 40 inches gives me a DI of 0.2, which is basically a zero technique. Great job, you did wonderful. And a DAP rating of 920 milligrays centimeter squared. Remember, DAP stands for dose area product. It's how much dose and how much area is going to that image receptor, to that area, right? So honestly, this would be some kind of inverse square law if I was asking about it. If I want to change my SID to 60 inches to reduce magnification, because we know that as we back up SID, we're reducing magnification factor, what should my new technique be to compensate for the change in SID? So again, think of a flashlight. If I back up my SID, yeah, I'm going to have less magnification, but the intensity of the flashlight on the image receptor is going to be less. So I need to use more mass to compensate. So whenever I get word problems like this, the first thing I do is I go through and I say, okay, there's a lot of extra information in here that I do not need to know. I already know it's going to say what is my new technique going to be to compensate for a change in SID. That tells me direct square law. So we're going to be doing a direct square law formula here. With direct square law, do I need to know kVp? No. Do I need to know mass? Yes. Do I need to know the distance? Yes. Do I need to know the DAP reading? No. Do I need to know what my new SID is? Yes. Okay. Then you just kind of fill it in. Direct square law mass old is going to be, what did I say? 20 over x equals, and then I look for my distance old, 40 inches squared over 60 inches squared. So my DSL formula is going to be 20 over x equals 40 squared over 60 squared. Then what I do, I recommend that my students get cheap calculators, because guess what? When you go to take your registry, they're not going to give you a fancy Texas Instrument calculator. They're going to give you a piece of garbage dollar store calculator. So get used to using a cheap calculator. So all I'm going to do is I'm going to square. The first thing that we do, please excuse my dear Aunt Sally, right, is I need to figure out what my distances are squared. So I'm going to take 40 and I'm going to multiply it by 40, and that's going to give me 1,600. So now I can scratch that out. Then I'm going to square my new distance, 60 times 60, 3,600. That's going to be my new distance squared. So now I have a new formula in front of me. 20x equals 1,600 over 3,600. And now it's just simple cross multiply, right? So I cross multiply these and I cross multiply these. I'm going to get 1,600x. And then I need to figure out what 20 times 3,600 is. So I still have my 3,600 on my calculator, times 20. Gives me 72,000. 72,000. And then to get x alone, I just have to divide each side by 1,600, which is going to give me x equals, I'm going to take that, what am I doing? 72,000, right? Divided by 1,600, 45. Okay. So, if I want to back up my SID to 60 inches, I'm going to need to increase my mass to 45 to still shoot a DI of 0.02. Direct square law.